Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm your host, Anna, and today we're covering some fascinating developments in space exploration, from NASA's mission delays to groundbreaking scientific theories about our universe. Let's get started. NASA has just announced significant delays in 3 important missions aimed at studying our sun. The primary mission affected is the Interstellar Mapping and Acceleration Probe, or IMAP, which was originally set to launch in spring 2025. This launch has now been pushed back to September at the earliest, with NASA citing the need for additional time to prepare flight systems. This delay has a ripple effect, impacting 2 other missions that were scheduled to share the same SpaceX Falcon 9 rocket. The Carruthers Geocorona Observatory, which will study Earth's outer atmosphere, and NOAA's Space Weather Follow-On mission, crucial for solar weather forecasting, will also have to wait. IMAP's mission is particularly important as it will operate from a special vantage point, the Earth-Sun L1 Lagrange point, about 1.5 million kilometers from Earth. From there, it will study the heliosphere, the magnetic bubble created by our sun that protects our solar system from interstellar particles. The mission has already faced several delays, having originally been scheduled for 2024. These postponements highlight the complex nature of space missions, especially when multiple payloads are involved. While delays can be frustrating, they're often necessary to ensure mission success and safety. The good news is that NASA reports all systems are being thoroughly prepared to ensure these vital solar studies can proceed with the highest chance of success. In other NASA news today, the Orion spacecraft's return from its historic Artemis 1 mission has revealed some concerning issues that NASA engineers are now racing to address. During its splashdown in the Pacific Ocean in December 2022, recovery crews noticed significant damage to the capsule's heat shield, damage that has prompted a serious review of the protective system's design. When Orion plunged through Earth's atmosphere, it experienced temperatures reaching a scorching 5,000 degrees Fahrenheit. While some wear on the heat shield was expected, the extent of the damage went beyond normal parameters. Large cracks appeared on the capsule's lower surface where the exterior bonds to the heat shield, raising red flags for future crewed missions. NASA's investigation has uncovered that the problem stems from how heat built up during the spacecraft's complex re-entry maneuver. As Orion performed its planned skip re-entry, which involves bouncing off the upper atmosphere before making its final descent, trapped gases expanded within the heat shield material, causing unexpected structural damage. This discovery has forced NASA to make substantial modifications to their timeline. The next crewed Artemis mission, originally planned for the near future, has been pushed to April 2026. Engineers are now working on 2 fronts, modifying the re-entry trajectory to better manage heat distribution and developing more permeable materials for the heat shield itself. These changes are crucial because while Artemis Y was uncrewed, future missions will carry astronauts. NASA can't afford to take any chances when it comes to protecting human lives during the intense re-entry process. The good news is that these challenges, while serious, are solvable. They just require additional time and engineering expertise to ensure crew safety. While on the subject of NASA missions, let's get an update on one of their most successful ones that is well underway. NASA's Parker Solar Probe is currently embarking on its most daring journey yet, preparing for its closest ever approach to the sun this Christmas Eve. The spacecraft is in excellent condition as it heads toward a record-breaking flyby that will bring it within just 3.8 million miles of the sun's surface. This incredible feat of engineering and human ambition represents the closest any human-made object has ever gotten to a star. The probe will reach its nearest point to the sun, known as perihelion, on December 24th at 6:53 a.m. Eastern Time. That's 11:53 GMT. During this critical phase, Mission Control will temporarily lose contact with the spacecraft as it traverses this unexplored territory. The mission team at Johns Hopkins Applied Physics Laboratory received a promising beacon signal through NASA's Deep Space Network in Australia, confirming that all systems are functioning normally. While the spacecraft conducts its close approach, it will be completely autonomous, with the next status update not expected until December 27th. This mission is pushing the boundaries of our understanding of our star. Operating in such extreme conditions, where no spacecraft has gone before, Parker Solar Probe is gathering unprecedented data about the sun's outer atmosphere and solar wind. The information collected will help scientists better understand solar phenomena that affect life on Earth and our technology in space. The success of this mission so far demonstrates the remarkable achievements possible in modern space exploration as we venture closer than ever to the very star that gives our solar system life. It's a testament to human ingenuity and our endless quest to understand the cosmos. Now for something completely different. In an exciting fusion of space history and modern technology, British startup Apollo Instruments has managed to miniaturize one of the most iconic pieces of moon landing technology, the Apollo Guidance Computer's display and keyboard system, known as the DISCI, into a wearable timepiece. This remarkable achievement allows space enthusiasts to wear a fully functional replica of the same interface that guided astronauts to the moon. The DISCI Moonwatch isn't just a novelty item, it's been meticulously designed to replicate the original Apollo 11 lunar module's interface at a precise 4:6:1 scale, complete with identical fonts and the characteristic green backlighting. The development team went to extraordinary lengths to ensure authenticity, even partnering with Academy Award-winning company Rosco to create custom color filters that perfectly match the warm glow of the original DISCI's incandescent bulbs. Users can interact with the watch using the same verb-noun command system that Apollo astronauts used, entering numerical codes to perform various functions. What makes this particularly impressive is that the watch can be programmed with the original luminary code, designed by Margaret Hamilton's team at MIT. This means enthusiasts can actually simulate Apollo mission commands, effectively recreating the same interactions that helped guide humanity's first steps on the moon. Beyond its historical significance, the watch serves as an educational tool, allowing users to upload custom code and use it for mathematics and physics projects. It's a brilliant example of how modern technology can preserve and reimagine the groundbreaking innovations that made space exploration possible. Moving our attention now to developments in China's space sector, Beijing-based private rocket manufacturer Galactic Energy has achieved its fourth successful sea-based launch of the Series 1 carrier rocket. The launch took place from a mobile platform in the Yellow Sea near Shandong province, successfully deploying 4 satellites into low Earth orbit approximately 850 kilometers above Earth's surface. These satellites, developed by Beijing's Guodian Gaoki, have joined the Tianqi network, which now boasts 33 satellites supporting various commercial applications, including forestry, agriculture, tourism, and environmental protection. This latest success marks Galactic Energy's 16th orbital launch of the Series 1 rocket, putting them ahead of their private sector competitors. The Series 1 is an impressive piece of engineering, standing 20 meters tall with a diameter of 1.4 meters. This solid propellant launcher weighs 33 metric tons at liftoff and can deliver up to 350 kilograms of payload to low Earth orbit. This capability has already enabled the deployment of 58 commercial satellites across their various missions. This achievement is particularly significant as Galactic Energy was the first Chinese private company to conduct sea-based rocket launches, beginning their maritime operations just last year. Their success adds to China's growing expertise in sea-based launches, which now includes 4 different rocket models operating from maritime platforms. Finally, today, in a fascinating development that bridges philosophy and physics, scientists have proposed the first experimental framework to test a long-debated idea about our universe's apparently perfect conditions for life. The anthropic principle, first introduced by Brandon Carter in 1973, suggests that our universe is remarkably fine-tuned to support life as we know it. This new research, published in the Journal of Cosmology and Astroparticle Physics, outlines specific conditions that could actually prove or disprove this principle. The test relies on 3 key elements: cosmic inflation, the existence of particles called axions, and the nature of dark matter. The researchers propose that if observations confirm cosmic inflation occurred, axions exist, but dark matter turns out not to be made of axions. This would effectively falsify the anthropic principle. Such a finding would suggest our universe's life-supporting conditions are highly improbable, challenging the idea that the cosmos is naturally configured to allow life to emerge. Today, In a fascinating development that bridges philosophy and physics, scientists have proposed the first experimental framework to test a long-debated idea about our universe's apparently perfect conditions for life. The anthropic principle, first introduced by Brandon Carter in 1973, suggests that our universe is remarkably fine-tuned to support life as we know it. This new research, published in the Journal of Cosmology and Astroparticle Physics, outlines specific conditions that could actually prove or disprove this principle. The test relies on three key elements: cosmic inflation, the existence of particles called axions, and the nature of dark matter. The researchers propose that if observations confirm cosmic inflation occurred, axions exist, but dark matter turns out not to be made of axions. This would effectively falsify the anthropic principle. Such a finding would suggest our universe's life-supporting conditions are highly improbable, challenging the idea that the cosmos is naturally configured to allow life to emerge. Several upcoming scientific missions could provide the evidence needed to conduct this test. The LightBird satellite, scheduled for launch in 2032, will search for signs of cosmic inflation, while ongoing observations of supermassive black holes could reveal the presence of axions. Meanwhile, various experiments are working to determine the true nature of dark matter. What makes this research particularly groundbreaking is that it's the first time scientists have developed a concrete way to potentially disprove the anthropic principle, moving it from philosophical speculation into the realm of testable scientific theory. The results could fundamentally change our understanding of whether the universe's hospitality to life is a cosmic coincidence or an inherent feature of its design. This is certainly one to keep an eye on going forward. Well, that's all for today's episode of Astronomy Daily. I'm Anna, and I want to thank you for joining me on this journey through the latest developments in space exploration and astronomy. If you want to stay up to date with all the latest space news, head over to astronomydaily.io, where you'll find our constantly updating newsfeed, all our past episodes, and you can sign up for our free daily newsletter. You can also find us on social media. Just search for Astro Daily Pod on Facebook, X, Tumblr, YouTube, and TikTok. Keep looking up, and I'll see you tomorrow with the Christmas Eve edition of Astronomy Daily, bringing you even more fascinating stories from the cosmos.